This project started after a meeting held on 2017 NI Week, where the Latin American researchers foresaw the benefits of working together in a cross-country initiative. They proposed a multicultural project between Federal Institute of São Paulo and El Bosque University, where each university picked up 5 engineering students to exchange knowledge. The Brazilian students shared what they learned from LabVIEW classes with Colombian students, and the expected result was evaluating the benefits of a cross-country training, where the students can reinforce what they learned from NI Student Ambassador Program and at the same time spreading to other students.
First, we prepared and translated a guide to introduce state machine theory using LabVIEW's interface and comments to Colombian students. For the guide, we proposed them to create a real-based problem, a pool hidden system. Our state machine begins when the tank is empty. Before we start, we have to know that B1 is the start button, and 1, 2, and 3 are the level sensors. Valve 1 and 2 control the liquids and trends in the tank. The valve 3 controls the mixture release of the pool, into the pool. Lamp 1, 2, and 3 are just indicators. So, M1 the mixer and the A1 the heater. So, on the first stage, the valve number 3 that controls the mixture release to the pool is closed. Okay. On the second stage, the valve number 1 is opened. Okay. The valve number 1 that controls the water entrance in the tank, and the heater is turned on. On the third stage, we have the valve number 1 closed and the valve number 3. The valve number 1 closed and the valve number 2 opened. The valve number 2 that controls the calcium hypochlorite entrance in tank. And the mixer is now turned on too. So, mixer and heater in this stage are both turned on. Okay? And fourth and last stage, we have the valve 2 turn it off, and the valve 3 opened to release the mixture to the pool.
Colombian students, with our help, were able to implement a VI with this behavior, which front panel resembles a SCADA method controlling industrial process. Due to the integration between NI hardware and software, that VI was easily modified to read and write the inputs and outputs of LVIS 2 Plus, available in our institute. Through this methodology, it was possible to implement a real problem on both. On the software, the good graphic interface promoted by the front panel facilitates visually the user on the platform and also the visual programming in the VI, making it easier to identify an error through the debugging tools, and on the hardware, because it's easy to communicate with the software. These advantages provided by LabVIEW and NI LVIS 2 Plus facilitate the project to be done separately, being programmed by Colombian students and physically implemented by us. According to this presentation, there is a desire to partner with other universities in other countries and let the students help each other during a new project.
It was a fantastic experience. We were able to have a new out-of-class experience of the NI Ambassador Program using LabVIEW and NI LabVIEW 2 Plus. It was awesome to teach students from another country who had the first contact with LabVIEW. They were able to see that with these solutions, it becomes easy to create an application with a clear interface and a clear communication with hardware. We hope that our institute support the initiative in the future and that our mentor, Alexandre Brincalep Campo, could continue to carry out the project with the other students and universities around the world.